Welcome to part 3 of our section 6.2 exploration. I hope you're all enjoying the lawnmower noises in the background. I definitely am. We're going to do some more examples. Hopefully videos 1 and 2 covered the basics, the theories, the whys, the hows pretty well. So this is just sort of a extra practice run on how to do some more of these, including what I think is going to be the text for some actual questions you might get asked. Or at least this is how I would word a question if I was going to put it on a test or a quiz. Wink, wink. It's going to look sort of like this. I'm going to ask you to evaluate an integral or find the volume of something. It will give you a function and I will describe a region. And just like we did in section 6.2, 6.3 and Calc 2, the very first thing I need you to do when you're looking at this region is draw a picture. So, that's not going to be a good picture. I want a bigger picture. We're probably going to have to erase some things halfway through this problem, because you've seen that these integrals get pretty long. Y equals x squared, we all know what that looks like. Y equals x plus 6, we all know what that looks like. So if it's bounded below by this and above by this, we're looking at this integral here. I wanted to do this problem because this is an excellent example of a problem where you need to choose very wisely which axis you're slicing it on first. If you want to slice this thing horizontally, you're going to have a pretty bad time. Because if you're slicing this thing horizontally first, your bounds are going to change halfway through the integral. On this bottom half, your bounds are going to be the left half of the parabola to the right half of the parabola. Those are the bounds for your first double integral. And then at this y value right here, I don't know what y value this is, but at this y value, you're going to have to switch to a second integral and go from the straight line to the right half of the parabola. And I'm going to assume that you don't want to do any double integrals, let alone doing two double integrals. So we're not going to slice it horizontally. That's a bad plan. If we slice this thing vertically, then we have a much nicer set of bounds. If you're doing vertical slices, the bottom bound is always the parabola, the upper bound is always the straight line. We can do this slicing vertically first in only one integral, and that's the goal. Anything that you can do with a single double integral, don't do it with two double integrals. Why would you do that? So, we're going to slice this thing vertically, which means that we need to set up an integral with some bounds. Slicing it vertically first means that dy dx is coming first. Y is going to go from bottom bound on y is the parabola, top bound on y is the straight line. Function we're integrating is x plus y. Now we just need to find the bounds on x. And once you have integrated on y, you can imagine sort of collapsing this across the y-axis. So your bounds on x just need to be numbers. And they need to be this number here, and they need to be this number here. Those numbers are not presented in the question as asked, so we need to find them. We need to find them. The special thing about these numbers is that they are where these two functions intersect, and so we can find them by setting these two functions equal to each other. X squared equals x plus 6 looks a lot like x squared minus x minus 6 equals 0. Looks a lot like x minus 3 times x plus 2 equals 0, which means that x equals 3 and x equals negative 2. You thought you were done with factoring polynomials, and you thought wrong. You're never done factoring polynomials. Factoring polynomials will haunt you Maybe not until the day you die. Maybe you will be done factoring polynomials when you stop taking math classes. Maybe that's the secret. I've never tried that, so I wouldn't know. You have to factor these polynomials to get these bounds. So, x is going to go from -2 on the back end to x equals 3 on the top end. That's what these guys are. Not -3. What am I doing? X equals -2 to x equals 3. This is what we got. So, this is what the integral looks like when it's been set up. And I said earlier that there's sort of two very broad categories of, or not categories, there's two big but relatively separate steps to doing these. And the first is just the setup. We started with this problem and we're 6 minutes into this video. We haven't integrated anything. 6 minutes just for setup. And that's going to happen. Setup is not easy. The good news is that setup is worth a lot of points. When I put questions like this on tests or quizzes, if you can get to here, you've got 60% of the points on the problem already. So, if you get to here and then you run out of time, or you get to here and then you don't know how to finish it, you're still doing pretty good. I'm going to erase everything so that I can finish this, because I'm going to need a lot of room to evaluate this. I feel like fractions are going to get involved in a big and unpleasant sort of way. Let me get this down. Integral x from -2 to x equals 3 of the integral from y equals x squared to y equals x plus 6 x plus y dy dx. This is a double integral. And now, 7 minutes into the problem, we can start evaluating it. First thing we need to do is integrate this with respect to y. That'll give me an xy and a 1/2 y squared. I knew those fractions were coming. Actually, let me move that over a little bit. I'm trying to be very conscious of the space I have. Okay, I'm going to slide it this way. We'll say I have an xy and 1/2 y squared, evaluating that at y equals x squared, and at y equals x plus 6. Dx gets to hang out on the back end. The integral x from -2 to x equals 3 gets to hang out on the front. Now I need to evaluate. X equals -2, x equals 3. That's not going anywhere. This is going to be x times x plus 6 plus 1/2 x plus 6 squared. That's the first piece of the evaluation, plugging in x plus 6 into both my y's, minus x times x squared plus 1/2 x squared squared dx. This is the second half of my evaluation. So again, you can see that the amount of algebra involved in finishing these problems is not small. It's pretty extensive. But it's algebra that we are certainly very capable of doing. X is -2, x equals 3. This is x squared plus 6x plus, I'm going to see if I can deal with the 1/2 and the squared all at once. So this will be 1/2 x squared. The middle term should be 12x, so cut that in half and you get 6x. And the back end term should be 36, cut that in half to 18. This will be minus x cubed and minus 1/2 x to the 4th. Can I combine any like terms? I got x to the 4th, x cubed, x squared. Yeah, I got some x squareds here. And I got a couple x's here. Yeah, we can combine these things. X equals -2 to x equals 3. What do we got? Start with the x to the 4th. So we got -1/2 x to the 4th minus x cubed plus, this is going to be 3 halves x squared. 3 halves x squared, 12x plus 18. That's, this guy got used, this guy got used, the 18 got used, the 2 6's got used, and the 2x squareds got used. That's everything. Okay. And the dx. Dx also got used. Okay. This is the part where we're done simplifying and we can check. Are there any y's left? There are no y's left. We now have a function of nothing but x's in an integral with respect to x, and bounds on x are numbers, so we are good to go. Maybe. Space is going to be tight. So let's see what I can squeeze in here. Negative 1/10 x to the 5th minus 1/4 x to the 4th plus 1/2 x cubed plus 6x squared plus 18x evaluated at -2 and +3. Ugh. We're going to need to do some calculations. And I'm going to need to erase a lot of this. If you don't have all of this written down, pause the video, write it down, make sure it's in your notes. I'm going to erase most of it so that I can work on this, have some space to work on it. Okay. So, when I plug this in, it's going to be negative 1/10 of 3 to the 5th is negative 243 over 10 minus 81 over 4 plus 27 over 2 plus 54 over 1 plus another 54, I guess. Okay, this is me evaluating this thing at 3. From this, I need to subtract what happens when I evaluate this at -2. -2 to the 5th is -32, so this is going to be positive. Don't need to write plus. This is going to be positive 32 tenths. -2 to the 4th is 16. This is positive 16 times -1/4 is -4. That will be -8 times 1/2 is another -4. Positive 4 times 6 is plus 24. -2 times 18 is minus 36. I don't want to do a common denominator for this. But I will. Negative 243 tenths minus 32 tenths should give me negative 275 tenths. 81 fourths. I don't have any other fourths. That's interesting. Oh, those fourths are going to... Okay. So the common denominator would be 20ths. Okay, I changed my mind. I'm not doing a common denominator on this one. If you want to know what the answer is, what the numerical final answer here is, then you should type all of this into a calculator, and it'll tell you a number, and hopefully that number is correct. I don't think that's a good use of my time right now on this video, and it's probably not a good use of watching me do arithmetic. Probably isn't a good use of your time either, so I will spare you that. I guarantee that this is a number. A computer can tell you what it is. I'll trust the computer when it does so. that's about all I have for us on the integrals over shapes plan. There are other examples I could do, but this was one example not quite finished in 15 minutes, and I feel like our time would be better spent trying some homework problems, seeing how it goes, and talking to me if in class if there's still issues. So I'm gonna call it. That's the plan. Do the homework problems, see what you think of them. Come talk to me about them in class on Monday. If this video gets reused in subsequent years and we talk about this in class on not a Monday, then pretend that instead of Monday I said whatever date we're next meeting.